Okay, looks like we started. So, hello everybody. This is Dennis. Couple of words about me since I'm new on YouTube. I'm a software developer, also a solution architect. And in today's video, I would like to share with you some pet projects that I created, which should help me on my job, and I hope in your job also. So I would like to introduce you Cortex. It's open source AI memory for developers. It runs locally, it is secure, and it is fast. Have you ever asked your AI assistant to implement something once, and after 10 minutes you're asking it again? And you are furious, you are super angry. You just explain it, and few moments later it tries to implement everything differently. It doesn't follow best practices, it doesn't use something, it's trying to duplicate your code, and so on. It's a problem. So here we are trying to fix AI context. It is hard, but I guess we are close to do it with this system. So Cortex. Idea of this project was to never explain your code twice. You just tell it once, your AI remembers it, and it never breaks. It always works and always knows what to do. So it's open source, as I said, it's free, runs on your machine, no keys, no API keys, you don't have to pay for anything. It just runs and it works. Problems that it solves, I probably already explained. So you just never explain it again and again. So how we were able to do it? And here, I tell what Cortex is about. So you can read the documents and so on. I will just go quickly to how it works. We have here our project on this diagram. So it's our code base. In this example, it's just Next.js application. You have some folder structure, some documents. You could have PDF files. Who knows? Whatever you want. It's just text information. So everything goes to chunking process. We generate embeddings and we put everything to a vector database. So why we do this? Why we don't try to use something like Redis to be super fast? Why we don't use something like OpenSearch to try to search for text? This is common problems that people think how AI works. It doesn't work like that. It doesn't look for text, which on the other hand is happening. I notice it in Claude CLI. When you try to implement something, when it does the job, you can see that it's looking for text. It's trying to analyze your code base, and it's looking for some keywords. It tries to use, I don't remember the packages they use, but it's open source. It allows you to quickly search for text inside your Git repository, but it's not the best way, and I guess this approach is much better. So we take the text and we generate embeddings. Embeddings is just numbers. In vector database, this term is called embedding. So it's just your text became numbers, and then it is embedding in the database. And when we try to search for text, we don't actually search for text. We are searching for a meaning, for intent. What user we're trying to search? Not the exact keyword, but the intent. He was trying to solve Stripe payments, or I don't know, any kind of. So you can say something like create a retry mechanism for failed Stripe payments. And after this, it will be done. Everything is nice. You commit it to your code. In a few moments later, you will implement retry attempt logic when charge fails. it's a completely different text, and it could be that the AI will implement it twice because it's like a new task. It will try to look for something like that, and if it will miss it, it will create it again. And when you have huge projects like with thousands of files, it is a real pain. I guess I don't have to explain it too much, because people who work with like professionally with such repositories, not something like a landing page where you have a couple of files, but I mean something real. When you have thousands of like lines of code and files, it is difficult for AI to do this job. So this is what we done. We scan the full repository, we push it to the vector database. Then when we talk to our CLI, with help of MCP protocol, it goes to our database, it fetches the data, recent state, and if it's not implemented, it will try to do it. Or maybe it will just learn from it. Maybe it can get some environment variables, it can follow the best practices, whatever you tell, it will be fetched, and it will be implemented in much better and more reliable way than it is done without it. Yes, it introduced some delay, but it is pretty fast, and you will not even feel it, but this difference really worth it. So this is the idea of the project, this is how it works. I can also tell you what kind of issues I had here by implementing this. It was the main issue was how couple of issues. First one was how to get rid of fluff. So in your project you could have something like node modules, you can have build folders, you can have test folders, some logs, some bunch of files which you don't need, and you don't want it to be synced in your database. So I took an idea from that guy who implemented Linux and Git, and Git was a really nice thing. So they have this .ignore file, and we created here, I created here exactly the same idea. So I use .cortex ignore file, where we have the same idea. We exclude all the folders which we don't want to be synced. All those node modules, all that like stuff that you don't want is excluded. So this problem was solved like pretty fast and easily. But second problem was much more interesting and difficult. And it was like, how do you constantly sync all the data? Like you when you start your project, you would be you will go pretty fast. Like you will do this, do that, like everything is fast, you are doing it, and then suddenly you will see that, okay, like bug here, bug there, this doesn't work, that doesn't work, context was lost. And how can you always tell AI what it should remember? I don't remember the context window, like how much symbols they can remember, like 2 million or 200k, this size of their memory. I don't remember, but it is small, and it always, whatever you will tell will be forgotten, like in 10-20 minutes, maybe an hour, I don't know. So we can give like some documents, Claude CLI file as an example. We will have to tell constantly, please update it, and so on. We can use some agents. We can create like an agent and tell, okay, if you have a problem, use this agent. If you do this, do with that agent. This idea with like millions of agents, one QA, one developer, project manager, and so on, like I guess it's far from reality. It is nice, it can work, it does the job, but it takes too much time for now. and it's still not perfect. It's working, but it's not perfect. And even with those different agents, with everything, it's difficult. So this idea about like how do we sync the data always and constantly was for me big one. And at the end, again, like thanks to this guy and his Git, forgot his name. Linus Torvalds. This guy, I really like him, but I always forget his name. Like, again, same idea with Git. Why on earth we should forget something if we constantly post updates to the Git repository? Why he created Git, I'm not sure if you know or not, but it's a nice story. I'm going too far right now, but anyway. He was like, it was difficult for him to manage different pull requests from different people, and at that time they were using like SVN, and they were not Git, so he created it for himself and he fixed our problem. At first he created Linux fix and fixed like, I don't know, like how many lives right now and how many servers use Linux, and then Git. So thanks to him. So with Git, again, Git helps us here. So I thought, okay, like if we have this issue with memory, it will always be forgotten. Why don't we push it like Git does? So I created a Git hook, and each time when something is changed, we are going to sync this data to our memory. In this way, there is no possibility on earth that our memory will forget something. You can talk to your CLI a lot of times, like bunch of it could be removed. Like I don't know, like maybe everything will be removed. Maybe you will completely change your mind. Who knows? So at the end, everything will be fixed, and you will be happy with the state you have. What you will do in this case? Exactly, you will commit it to the Git repository, and we have a Git hook. At that point, we will look into Git difference, and all the files, all the updates will be pushed again to our memory. Our Cortex will remember it. So those things that were difficult to handle, I described you ideas that I have right now. Who knows, maybe tomorrow everything will change, maybe tomorrow somebody will create something better, but for now it is something which helps already me, and I hope it will help you. Okay, let's see how it can be installed. Here you can read like what we do here, like we create chunks, how we create them, which modules, which packages we use, and so on. Like in short, we use those technologies. We use TypeScript, Node.js, Postgres as a database with some PG vector like module which allows us to create embeddings. We use MCP protocol to allow our CLI to talk to our Cortex, and I don't remember the model name which we use in Olama to create those embeddings. It's one of the most popular ones. So yeah, it just couple of words about technology stack here. How to install it? I thought it would be useful to just create like a submodule. So if you have a project, you can add it to your project. I will show you. So I have here a project, some small project, I don't know, like around 500 files, not more. Then what we have here? We have here Cortex, install it as a submodule. Inside Cortex you have Docker Compose file. You have hook, which will be installed as a Git pre-commit hook. You have docs. Here you have AI memory agent which we are going to use in future. As an example, you can look into it, your mission, how you should work, and so on. Then we have Cortex ignore default file. This one was created for Next.js. It will work for your TypeScript, most probably project. But if you use .NET or something, please create a pull request. Let's set it here to the docs folder. Let's allow people to have this example. I don't know, like anything you want guys to improve, any bug you found, like whatever, any idea you have how to improve it, how to make it better, please create a pull request. Let's merge it and let's make our life easier for everybody. Okay, so you cloned your repository. Second step would be to copy, again this command for Mac, but for Windows it's different. Like copy your Cortex ignore file to the root of the folder. It should be in the root. It will look like docker ignore, Cortex ignore, git ignore, another ignore file. And this file should exclude everything which you don't like. You don't want to have binary files in your database, most probably. You don't want to have there like npm packages. You don't want maybe secrets, maybe who knows. Like you want to exclude everything. You does it. Nice job. Second step is to run our Olama with embedding, and it could be that you're running it already. Maybe you can just use, I don't know, maybe you use LM Studio or whatever. You can do it like that also. Who knows? But here is an example for Docker Compose. We have this Docker Compose file. All you have here is Olama. You have see here Olama. This should be model which we will run also. So all we need to do is to run it. I have already run it unhealthy somehow. I'm not sure why. It should be running fine. I'm not sure why it's unhealthy. It's probably bug inside IntelliJ, because here it looks like everything is fine. Yeah, everything is fine and it's running nice. So first time when you will run it, it will try to pull the models and it will tell you, okay, like everything is fine, model is ready. It means that you can go to the next step, and the next step would be to run npm setup. Let's see what we have here in npm setup. We should go to our packages on, and in setup we have to be setup folder. So in order to start embedding data to our database, we need to have some tables. Those tables are going to be created here in this step. You just run it, it tells okay, fine, and it immediately starts syncing everything. I have 522 files in this project. So for me, it will be, I don't know, maybe 20 minutes, maybe half an hour. It depends on your machine. And I didn't mention it, but Cortex was designed in a way that if you don't have NVIDIA GPU, RAM memory will be used. If you have NVIDIA, CUDA is going to be used. It will be faster for those guys who have some NVIDIA machines, but for those who don't, I don't. I have a small one second. Not a small machine, but My graphic card is like literally nothing, but I have 64 gigabytes of RAM and more or less nice Intel. So it's going to work more or less fine for me. Speed is like in 1 minute we done 10%. Oh, not 1 minute, almost 2 minutes, 10%. What's nice about this process is that if it will fail, I can just stop it right now and I will continue from scratch. It won't be broken. We will not continue from very beginning because all the files are indexed there. And if you synced already a file, it will remember that okay, this file was synced. You don't have to sync it twice. So process will continue. And yeah, this is how it's going to work. After that, we will have to add MCP, configure our MCP project. And most probably if you already use Claude CLI or anything like that, you will have this MCP JSON where you need to add this MCP server. So this MCP server also starts with our Docker Compose. When you start it, no, it's probably here. I don't remember where is it, where to show it to you, but it will be running. And what you're gonna to do next is to go to your MCP servers, and you should see your Cortex to be connected. Once it's connected, you can install GitHub. Oh, that doesn't really matter. You can install GitHub without waiting Cortex to be ready, but no, you should have it. So Cortex should be running because otherwise you won't be able to sync. No, you would be able to sync, but it's so complicated. I have too many projects, too many stuff to do, and everything is mixed up in my head. So you need Cortex to be running in order to sync the data when you do your commit, because it's going to work with through MCP server. This first process, when we do it, we run it like manually. Everything goes, this first initial sync goes directly to your database without need to call MCP. It just directly goes straight forward to the database. You have the data, and once data is there, you will have somehow right now talk to this database, and this is where MCP comes in handy. You will need it again. Git pre-commit hook will just also sync the data directly to your database. But when you will start coding, this is where you will need MCP. You will try to, for example, implement something new, and your AI should be able to sync, to communicate with Cortex. So here we need it. Okay, step number 8: create Cortex memory agent. It's recommended. It should be updated. It's not recommended. It is required, because otherwise, how you need something like that? You need to say agents. I'm not sure. I probably don't have it right now. Yes, I don't. So let's do it together. I don't want this again. Agent. We need to create a new agent for this project. Create with Cloud recommended, and select create new agent, follow the prompts, name, okay. Or you can just copy it with this command line. So it will be in Cortex here. This I can open it somehow. It should be here in this file. Yeah, I was able to open it, but I need to close this. So this agent was generated already by Claude, and it knows how to work with it. So what we can do, we can just take this GitHub link, and in our AI agent we can tell that we want to use Cortex as our memory, and this agent should allow us to use it. So Claude MD right now, Claude CLI will go right now. It will read this MD file. It will learn what is it, how it works, and it will just know how to talk to the Cortex and so on. Okay, we can try to do it, and please date the use it, something like that. So we are going right now to generate this agent. This agent is going to be added to Claude EMD file, and next time when we will ask to implement something, Claude EMD will tell us that okay, now we can just connect to this database with help of MCP and use it. So here we are done. Git pre-commit hook we already discussed. This is information about MCP tool, what kind of things we can do. We can query the database, we can sync the database, we can see stats, we can init it, we can list index files, we can delete it if we want. So here I would say we need everything, continue, model, okay. We can select, I don't know, let's do pink. So it will be eye-catching when we will see when it's used. Uses engine by any feature fixing bugs, refactoring code, exploring Codebase. This one, yeah, it's nice. Press enter to save. So we have Cortex memory agent. 6 agents already. Okay. Cool, we are done. We can go to our agent. Where is it? Where is my agent? Claude agents. Here it is. I'm not sure why this .agent folder here exists. So those agents, yeah, you see, it knows how to communicate, and it's more or less fine. Guys, since my project is like kind of big, it's already 10 minutes and we just think like 30%. It's, I don't want to sit here for another half an hour just waiting it to be done. Let's see what we have also. We have Cortex ignore, we already discussed it. We have some Cortex config. This file is also interesting because we could have situations where we can have a file which is like 500 megabytes. It could be huge PDF file, who knows. You don't want it to be synced, or maybe synced later. So for now we can exclude it by setting here like a memory size. All those files which are huge in memory, they will be skipped. And this means like 50 megabytes. I don't have it right now because I don't have any such files, just in case, so you know, you have it. Troubleshooting, mostly it could be due to some Llama didn't start it or whatever, I don't know, like you can read it here. FAQs, is it really free? Yes, it is. Contributing, yeah, contributing is a huge topic, guys. Project is new, it's like super fresh. I just created it, I started using it, I see that it works, and I hope it will work for you. But we're all different, we have different machines. Right now I use Windows and 64 bits, so who knows how it will work on 32 bits. I don't know how it will work on Mac. Documentation could be updated, we can improve README files, we can do a lot of things here. So any bug request, any pull request, any idea, everything is appreciated. Please do it, let's create it together, let's make it much better than it is right now, and I think everybody will win at the end. A similar project. This is project that I found after creation of this one. I thought like usually everything that I want is already created by somebody else. I am happy to use it. I always thankful for that. But in this case, I haven't seen anything close to this, so that's why it was created. Suddenly, I found this zip or zep. Not sure how to pronounce them. I don't know who they are. I'm not affiliated to them anyhow. And they try to solve similar thing. They say that agent context is hard and we fixed it. Okay. They took all your data, they do something here. Graph constructions, probably it's embedding, but told differently, or I don't know how those graph works, what it does and how it works, but the idea is that they're pushing it somewhere to the memory to keep this context, and then when you talk, you have this data. It most probably is the same idea as we have, and they say it's quite fast. This is graph, okay. More accurate, faster, more efficient. Yeah, most probably it's true. But I never use them. Have no idea who they are, how it works and what they does. I see that it has a price and has some limits. So maybe if you're not happy with Cortex, it doesn't work for you well, maybe you will find useful to use that project which you guys built, who knows. I just want to share it also here to promote them somehow. Maybe it will not help him because I have 0 subscribers and nobody knows me. And oh yeah, here I left to buy me coffee. If you found this project helpful, you can buy me coffee. I definitely need it, so I would appreciate it. Okay, here we don't see too much commits because I squashed everything and it was some, believe me. It wasn't done in one day out of nowhere. It took a while to implement it. It's kinda, it's not a big project, but it took a while to implement it and fix different stuff to make it work. Now it's more or less fine. I guess people already can start using it. So thank you guys for watching this video. Wish you all good luck, happy coding, and see you in the next video. I'm planning to continue this project, continue posting different AI videos, different stuff I do, maybe some vibe coding, some challenges, and so on. So see you next time. Thank you. See you. Bye bye.